wrong for different pattern. Okay, you can think of it as a pattern. Right? So it means that you do this in your graduate project, you have to look at data and then decide if there's a trend, if there's seasonality, then I'm going to pick which forecast model I want to apply. Right? And this has to be done by, first, you just do the scatter plot and then you're going to see what's going to happen. Okay, I'll go quick now. We haven't gone to the calculation yet. So when you do this decomposition, there are two types of model that you can do. There's multiplicative model and additive model. So you do the multiplicative model, all the terms, trend, seasonality, cycle, and randomness, each term will multiply each other. Compare if you do the additive model. So basically you forecast each part separately and then you just add them together. Right? So it's just there are two ways of combining all those terms together, whether you multiply them or you add them all together. Right? So it's always in these two forms. Every time you do this, everyone assumes that your errors, okay, is going to follow that normal distribution with mean around 0. Right? So that's the assumption that we all use. And it's going to show up later on why this is important when we do the regression. Okay. So that's the first one finally. So the first one that we call is called moving average. Alright. So the only parameter we use in this moving average is n, which is the number of periods that you're going to use to compute the moving average. Right? And it has to start from 2, 3, 4, 5, 6, and so on and so on. Right? So the concept is you're going to take the average of periods in data point. So let me have this. This is going to be n. Right? I'm so bad at this. Okay, periods n data. So the next forecast is the average of the most recent n data from your time series. Right, so it's going to be the sum of demand in previous n period divided by n. So why is this one good? Okay, because this method tends to smooth out the short-term inequalities in your time series. So you're going to remove all that. Right? That's what we do. Very simple, very straightforward calculation. Right, so this in terms of mathematics, it's going to be forecast. In the future, 3 plus 1 is going to be the summation of all the y in the previous n period. Okay, maybe Wednesday, Tuesday, Monday. So today is Thursday, and maybe you do this for over 3 days. Okay, and it is now Wednesday, for example. So you can sometimes use the y, sometimes use the t for the actual value. Right? So don't be confused. Right? But f always going to be the forecast, okay, and y is the actual value. So let's look at example. So we have data from January to December for the last year. And let's say we do MA3. Okay, so 3 is the number of periods. Right. So you can see that in this one, the most important thing is, you can see that you don't have any forecast in the first period. None. Because you need at least 3 periods to compute the forecast. So the first period that we have the forecast is in month April. You see nothing in Jan, Feb, and March at all, because you need at least 3. Okay, but if you use FA2, Okay, your first period that you're going to have the forecast is in period 3, not 4. Alright, so how do we compute MA3? So it's going to be 10, 12, 13 together divided by 3. And in the next period is 12, 13, 16 average. And keep going, keep going. Right? Okay. So you see that if I have to compute the moving MAD, for example, okay, I only care about this data set to compute the MAD. I will not use 1, 2, 3, and I will not use the last one because I cannot compute the error. Right. So whatever I use is going to be divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. So the summation of absolute deviation, then divided by 9 in this case. So that's moving average. Next one is called weighted moving average. Okay, so similar to moving average, except you put different weight in each term. Okay, so you're going to put this W as a weight between each one. Right, so it's be W1 times Y1, W2 times Y, T minus 1, and so on, and then you divide it by the summation of all the weight together. Okay, so the weight in each period multiplied by the actual value divided by the summation of the weight. Right, we call that weighted moving average. So in this case, you don't have to worry about what weight you're going to use. Okay, I'm going to ask you to do this. I'll give you the weight in each period. Alright, so for example, you may say, okay, for the last month, the weight is 3. 2 months ago is 2. 3 months ago is 1. Alright, so you put more weight on the data from the last month, not so much from 2 months ago, and the smallest in the 3 months ago data. Alright, 3 to 1. And that's why you divide it by 6 because that's the sum of the weight. Okay, 3 plus 2 plus 1. That's an example. So in this case, alright, again, the first period that you're going to have the forecast in period 4 because it's the weighted moving rate of 3 months. Alright, so it's going to be 3 divided by 13 right here, right? 3 divided by 13 is 12. Divided by 2, multiplied by 2, sorry. 3 divided by 3 multiplied by 13, 2 multiplied by 12. And last one is 10 multiplied by 1. Right, and then over 6. And you keep going and going. You see a lot of calculation. That's why it's very easy to make a mistake. And I can change the weight also. In this case, I change the weight to 1.5 and 1.1. Then my answer is going to be 13 multiplied by 2, 12 multiplied by 1.5, and 10 multiplied by 1.1, divided by 2 plus 1.5 plus 1.1. Right. So imagine I give you this exact data. Okay. This is where you're going to make a mistake somewhere in this number. It's not like Excel, you just do one then copy all the formulas. Okay. This is your calculator we're talking about. And this is for the last one, right? So 14 divided by multiplied by 3 to 16 and 18 multiplied by 1. So that's how we got the number. And so that's for weighted moving average.
ยกสอง มันมาจากฝืนต้องไปดูฝืนเลยมันน่าจะมาเดียวกันน้องหาด้วยจำนวนอ๋อไม่ใช่แล้วเหมือนกันเขียนไม่ถูก
Okay. And we can do this in Excel. Okay, we're not going to talk about that yet. Alright. So that is called exponential smoothing average. Okay, so there are two names for this one. First one is called ES, okay, we just have the name saying exponential smoothing. Or some people say it's another type of moving average. Right? So it's mean that when you go back to the moving average that we have before, okay, in some books we call this simple. Okay, we call it simple moving average. So when you just take the average of the last previous N data, we call this simple moving average. Okay, sorry, it's just the word simple, just add it in there. But in this case, it's not simple, we call it exponential moving average. So it's another type of moving average. Okay, so just add this adjective. So in this one, okay, the parameter is going to be this sigma, okay? Oh, sorry, it's alpha, sorry, not the sigma, alpha, like that. Okay, you're not going to see sigma in the equation, you're going to see alpha. Alright, so the forecast is going to be equal to last period forecast, right, plus alpha multiplied by last period actual demand, subtract last period forecast, where alpha is between 0 and 1. Alright, and this alpha has a name which is called a weight or smoothing constant. Alright. And when you do EMA, they're not going to ask you for alpha in any website that you want to do the technical graph. Alpha is equal to, okay, 2 divided by 1 plus n. N stands for the number of days. Okay, so that we translate into alpha. For example, you do EMA 4 days. Okay, alpha they're going to use is going to be 2 divided by 1 plus 4 or 0.4, for example. Which I'll show you the graph next. Okay, what is the equation is different, of course, but when you do the forecast, you can see that there's a difference with these two lines. And considering if you compare simple and exponential moving average, this one will be harder to compute, okay? And you have to be more careful when you compute this one to get the answer. Okay. Let's put this. And this is the equation. Alright, so it's going to be equal to okay, ft plus 1 equal to forecast in the previous period t plus alpha multiplied by yt subtract ft. Right, so that's the equation that we use. So now in current period t. Okay, so we are in period 7. Alright, your f8 is going to be equal to f7 plus alpha times y7 minus y f7, sorry. So you talk in English, this is what it means. Okay, the idea is simple. The new estimate or the new forecast is going to be equal to the old estimate, which is F7, right? Old estimate. Plus some fraction of the error in the last period. Yeah, this is the error. Alright, this is E7. Right, this is E7. Okay. So it's going to be F7 plus alpha, fractional of this
ในวงเล็บ
E7. So that's what it means. We do exercise soon, so that you won't be so sleepy anymore. I'm sleepy too.
มีเซเว่น
And again, we come back to that. Talk to example first. Okay, so this is
รวมอัลฟา
example.
ไม่
So
รู้
let's do this first. So in January, okay, let's say that February demand for the second car order was going to be 142. So this is your FT equal to F2, 142. So your current period is in period 2. Okay. And let's say you finally realize the actual demand and it turned out to be 153. Alright. And use alpha equals 0.2, then the forecast for March is going to be equal to 142. Which is X2 not Y2 plus 0.2 which is alpha multiplied by FT, right? 153. Sorry, YT. 153. Subtract F2 which is 142. And that's how you got the number. Or in a nutshell, that's what it means by F3 equal to F2 plus alpha Y2 subtract Y2. And you keep going and going until you get that thing's done. So this will represent your F3. You don't have to write everything. Okay, just take note the only important stuff. Because once you get the concept, what it means, then you know what to do. This is when you want to do this for April. Alright, for April it's going to be F4, right? So F4 is going to be equal to F3 plus 0.2 times Y3F3. And this is why it's important. Because if you get this F3 incorrectly, then you're going to get this number incorrect also. Because this F3 will be used to calculate F4. F4 we used to calculate F5 and so on. So if you got the first one incorrect, the whole thing is just garbage, right? Just trash. So make sure you got this correctly because it's a sequential calculation. That's why emphasize that it's very important to get it right. So the quick concept is which alpha should I use then? Alright, so probably not today, but I mean later. Okay, I'll show you how you can use Microsoft Excel server to calculate the best alpha. Alright, so an alpha should be between 0 and 1, and I can pick you the best alpha. That give you the lowest. Either it's going to be the lowest MAD, or lowest MSE, or lowest MAPE. I can figure out that for you. But for now, just assume that alpha is given. So don't worry about figuring out the best alpha. But when you do this in practice, you're always going to try to find the best alpha to minimize MAD, to minimize MSE, or minimize MAPE. Do that without any problem. Okay. Alright, so let's look at this example. Alright, so this is going to be you have 8 quarters, and you have this Y1, Y2, Y3, and this is going to be your F. Alright, and this is when we apply our alpha equal to 0.1. Right? This is important. You're going to see this in your midterm pretty sure. So note, when you do this, F1 will be given to you. Right? If not, you can use Y1. But in this case, Y1 equal to 180, but F1 is not equal to 180. I specify that it has to be 175. So this will represent your F1. Then from F1, you're going to compute F2 according to F1. Right? So it's going to be equal to F1, right? 175 plus alpha multiplied by Y1, 180, subtract F1, 175. And that's you was 175.5. Then from that, I can calculate F3, right? It's going to be equal to F2, 175.5 plus alpha 0.1 subtract Y2, 168, subtract F2, 175.5, and so on and so on. Right, so you see that? This number will be used in our calculation. And in this case, you want to calculate MAD, MSE, or MAPE, you're going to divide it by 8. Because you don't have Y9, but you can calculate F9. Right? This is F9. Right? So this number is F9, right? But where's Y9? We don't have Y9. So that's why if you calculate MAD, MSA, or MAPE, you will divide it by 8, not 9. And this is the result when you get 0.5. So in exam, I know that you probably don't want to write this whole thing, right? But in case you get this number wrong, okay, I can still give you more partial credits. If you just compare it, you just put everything here, right? So be careful with that. So if you have time, try to write it down. Okay, it's gonna help you check with your calculator also. Right? Compare, use the calculator and just tell me the answer. Worst, if you got it right, then no problem. But if you get it wrong, then that's gonna be a problem. So that's why when you, according to that problem, when you want to calculate MAD, this is how we do it. So this is your Y, this is your F, alright, and this is This is your absolute deviation. So these two numbers subtract each other and take deviation, that's 5. These two, 7.5, and so on. So instead of you sum all this, equal to 82.45, and you divide it by 8, that's your MAD. And then I can compare this MAD with MAD if I use alpha to 0.5, you got this MAD 12.33. You see that this one is lower than 12.23. So the conclusion is we have to compare these two models. Alpha is at 0.1 is better because it has lower MAD. Okay, so that's the best choice. If I have to pick between alpha to 0.1 and alpha to 0.5.